Hello everyone, this is Math1055 live Q&A number 8. As usual, you can ask me questions using the chat, and we'll go through problems related to this week's videos using the item pool website. So head over to itempool.com/math1055/live, and I will give you the first problem right away. In the meantime, if you have questions, just ask them. So here's the first question. You might think it has nothing to do with the vectors, because this is the third part of the module now we started, which is related to vectors. So the question is, how many water molecules H2O are produced in the following chemical reaction, where we have glucose and oxygen combined? Basically, burning glucose gives us carbon dioxide and water. This is something that you are doing right now, or when you are working out or something like that. You are basically burning glucose when you are thinking. So it's a simple equation, simple chemical equation that you have to balance to figure out how many water molecules are produced on the right-hand side. And it's simple because you just have to make sure that you have the same number of everything on both sides of this equation. Okay, so you can input. Yeah, I hope this won't bring back some bad memories or anything, because oh, too bad, I'm sorry. Yeah, I mean, this is good stuff actually. I know that teachers can make it, the way they present it can make it like a bad experience or bad thing for you, but these are actually fantastic things, I think. So anyways, this is just a warm-up, and you will see, I will just quickly tell you how it's related to vectors. So the reason I included this warm-up question is just to show you that vectors are not just about arrows pointing in space or stuff like that. Vectors can be used in so many different situations, and this is just one of those. Of course, it's a very simple one, so you don't really need to use vectors to answer this question. But in more complicated situations, you might actually end up using vectors or solving some sort of linear equation to balance an equation like this. Okay, so we already have 60-something submissions. Let me just reveal the answer. You won't be surprised, I hope. So the answer was yes, 6. It's basically just looking at the number of either hydrogen or oxygen sort of atoms, and making sure that you have in total 12 hydrogen atoms on both sides. So you need 6 of the water molecules to make up, to balance the equation. But my point is that if you make a vector, basically a triple of numbers, in the following way. So here you put how many, in the first component you put how many carbon atoms you have. In the second component you put the number of hydrogen atoms, and the third one the number of oxygen atoms, then basically any equation like this can be, like this chemical equation here, can be turned into an equation of vectors, because the first thing you have is 6 carbon atoms, 12 hydrogen, and 6 oxygen. So for example, glucose would be represented by this vector. So this is glucose. And to this we add, what do we add? Oxygen, I think 6 of those. Well, they come in pairs, so something like this thing, I suspect. Yes. So this is, oops, this is what we add to it, and we get, on the other end, we get carbon dioxide. Yeah, 6 of those, so 6 carbon atoms, 0 hydrogen, and 12 oxygen, plus some sort of the number of 0 carbon, 2 hydrogen, 1 oxygen, and this was them. Okay, so basically, oops, this is the equation we had to solve for n, and you can see that it's basically just if you look component by component, you can solve for n, because here you have 12 in the second component, and you have zeros everywhere else. So in order to get 12, you have to have 6 times 2 in this, for this vector. Okay, so that's the basic idea. It's a very simple equation, but there are much more complicated chemical reactions where equations like this and turning everything into vectors or systems of linear equations can be helpful. Okay, again, the basic takeaway message is that vectors can be used for not just arrows pointing into different directions, but here is one of those problems. So which point does the vector 1/4 of OA plus 3/4 of OB correspond to? And you can see this figure right here. We have the origin, the point O. It is a fixed point in space, and then we have 2 points A and B, and these position vectors from O to A and to O, and from O to B. And there is this combination of those vectors. We take OA, shrink it so it's 1/4 of its size. We take OB and we shrink it so it's 3/4 of its original size, but pointing in the same direction. We add those up, and the question is that which point does this linear combination of OA and OB point to? Okay, so basically we are taking a combination of the red and blue arrows, so OA and OB, and the question is which point is it going to point to? Well, I just you probably you can see, but there is that black line segment connecting A and B, and there are 3 points dividing up that line segment into 4 equal parts. So we have point P, Q, and R, basically. And the question is, which point does this combination, this linear combination of vectors point to? All right. In the meantime, let me just make a similar drawing for myself. Okay, so there are something like 70 people who have already voted. You can still go to this website itempool.com/math1055/live and vote for your answer. Again, the thing here is we take this linear combination of two vectors, and the question is, what do we get in the end? We'll get a vector which will point from O, from the origin, to one of those 3 points. And actually, this sort of combination of two vectors is sometimes called a sort of a geometric linear combination, because if you notice, the coefficients that multiply the vectors are between 0 and 1, and they sum to 1. So the sum of 1/4 and 3/4 is 1. So that's a special linear combination of these two vectors. Okay, let me perhaps finish this poll and reveal the answer, if that's okay. So yes, the answer was point R, so the third option. Just to quickly convince everyone that this indeed was the correct answer. Basically, what we are doing is let me just show you. So here we have the similar drawing, and basically what happens in order to get P or Q to P or Q or R, what we have to do is we have to go from O to A and then to go along this line, sort of some distance. So this line, this vector connecting O to B, so that black vector along this line segment is nothing but, so this is from A to B. This vector is basically OB minus OA. So the difference of these two vectors. Always, this is something that's true in general. If you want to connect 2 points with a vector and have the vector point from point A to point B, you just have to take the difference of the position vectors, starting with the end point, well, with the position vector pointing to the end point, and subtract the position vector pointing to the starting point. And the idea was that each of these points can be expressed by taking OA and some multiple of AB, right? So, for example, if we want to get sort of OP, so this point, then we would add this vector shrinked to 1/4 its original size. And similarly for OQ, S would be 1/2, and for OR, S would be 3/4. Yeah, 3/4. So and if you calculate this combination using that AB is this vector, you will get indeed 1/4 of OA plus 3/4 of OB. That was the original idea, and this is a good exercise, basically showing you that you can always express sort of the weighted, sort of always express a point along a segment connecting two given points using this sort of linear combination, this weighted sum of the two vectors. Okay, so far so good, I would say. Now, here is the next question. I'm trying to make these sort of interesting in at least, well, I'm trying. They might not be too interesting, but here we have two sailboats, both A and B, which are traveling at speeds of 6 miles per hour and 8 miles per hour respectively. So both A is going north, up north, at a speed of 6 miles per hour, and boat B is traveling at 8 miles per hour due east. The question is, what is their relative speed? So the relative speed is basically the length of the difference in their velocities. So basically, this relative speed would be the speed at which someone in boat A would see boat B sort of getting away, or getting farther and further away. But basically, it's just if you would be traveling on boat A, you would measure this speed for boat B. So this is the relative speed. But basically, I have given you a very strong hint that what all you have to do is take vectors, the vectors VA and VB, calculate the difference, and compute the length of that vector, of that difference. And hopefully this figure gives you, well, a very good hint at the form of these vectors, or the coordinates of these vectors, if you want to use coordinates. And it's very important that I have chosen some very special directions for these boats. So one is going due north, the other one is heading, is bearing east. Okay, lots of answers. I'm curious to see as to what all these answers are. By the way, the intro video, you might have noticed that there were vectors all over this plane, and we have these lines sort of following these vectors. Basically, it was a fluid flow, which is again something that uses these vectors, these velocity vectors, all over sort of drawn on the plane, and then each sort of particle or each small volume of the fluid or the water has to follow these vectors at that speed, which is given at each point in the plane. At the end of the lecture, you will see this video again, and you will notice that there are certain spots where sort of the fluid flows out of, so acts as a source, and the origin acts as a sink, because it's sort of where all the water is flowing. You will see how that goes. Okay, so we should not give away answers or try to we'll see soon, I mean. But let me just reveal the answer anyway, because there are a good number of people who have already voted, and there are a few more of these questions to get to. So yes, the correct answer was 10 miles per hour. Someone has actually experimented with sort of this item pool thing, who has written 6 squared plus 8 squared to the, I guess, 1/2. So basically taking a square root. And yes, that was the idea. You had this two vectors being perpendicular to one another. So one has length of 6 units, the other one has length of 8 units. And we were interested in the length of the vector connecting the endpoints. So basically, that was the length of the difference of the two vectors. And since we had, so let me just quickly give you some sort of vector solution. So the velocity vector of both A was basically you could coordinate the plane and say that the velocity vector was 0, 6, had coordinate 0, 6, and both B was heading east, so in the positive x direction with velocity, with speed 8 miles per hour. So basically these were the two velocity vectors for the boats, and all we had to do is to take these this difference, which we do coordinate by coordinate. So we have 0, 6 minus 8, 0, so that's minus 8 and 6. And then all we had to do is just calculate the length of this vector, which can be done by, well, using the Pythagorean theorem. So it's just the square root of the squared sum of the coordinates. And I have chosen some very special speeds. So you get a Pythagorean triple. So that's 64 plus 36 under the square root. So that's root 100, which is 10 if we are actually looking at a length, so a non-negative number. So that was the solution. I hope it was clear. Well, let's move on to the next question. Okay, it's a bit of a, the figure is a bit too large, so it doesn't fit in the on the image. But basically what we have here is we have a triangle with vertices A, B, and C in space. So we have this triangle sitting in space in some orientation. And what we are looking for is a fourth point, point D, making sort of completing this triangle into a parallelogram. So this is the image I want you to have. Let me try to adjust it a bit. So this is the image I want you to have in mind. So we have this parallelogram here going from A to B to C to D to A. And you have 4 options. So you have 4 options for the possible, for this fourth point given by its coordinates. So let me just say that point A has coordinates -1, 0, and 2. Point B has coordinates 0, 1, 0, and point C has coordinates -1, -1, and 0. And the options for point D are the following. We have 0, -1, and 2, or 0, -2, and 2, or -1, 1, and 2. And the final possibility is 0, 0, 2 for its coordinates. So basically what I'm asking you to do is to find the fourth corner of this parallelogram, so that the segment, the side AB is parallel to DC, and AD is parallel to BC. It's not a very hard problem, I hope. Requires a tiny bit of sort of calculation, but not extremely long or anything. Okay, so there are something like 60 something votes already in, which means there's still a good number of you who haven't voted. You can go to the website and cast your votes. Again, sort of the big hint is that it's a parallelogram. So the side AB has to be parallel to DC, and similarly AD has to be parallel to BC. And has to be parallel in this case means, well, not just parallel, of course, I mean, they have the same length, the parallel sides, meaning that the vectors representing them are equal. So that's a big hint. Okay, I think with more than 70 votes, we could finish this poll. Let me just do that. Okay, I hope this worked. Let's see. So yes, the answer was option B. So the coordinates of the point D were 0, -2, and +2. Okay, and the basic idea here is just to, well, you could do it in multiple ways, but the basic idea is to realize that that if you take the vector, let me try to draw this. So here is our parallelogram, A, B, C, and D, and you have some sort of origin fixed in the coordinate system, and you were given, well, you were given these three vectors. So you could calculate this vector right here. What is it? BC, and you could calculate then this sum going from O to B, and then adding BC to this. So this is OA. So to get the coordinates of D, you just calculate OA plus BC, meaning that you take OA plus OC minus OB, these position vectors. So all you have to do is, well, let me just go back to see the coordinates. You take -1, 0, 2 plus 1, -1, 0 minus 0, 1, 0. So all you had to do is calculate this combination of vectors. So for the first coordinate, you get -1 plus 1 -0, that's 0. Then you have 0 -1 -1, that's -2, -2. Then you have 2 plus 0 minus 0, that's just 2. Okay, so this is how we got 0, -2, and +2 for the coordinates of point D, and that was option B in this question. I hope this was clear. Let me just show you the drawing again. So basically, all we used is that the sides, the parallel sides are equal, so the vectors representing them are the same vectors. Because for a vector, all we care about is its length and direction. Okay. Now let's move on to the next question. Okay, so here it is. It says, well, the story is that a bird is flying in a straight line with velocity vector v that is given as a linear combination of the standard basis vectors I, j, and k. So the velocity vector is 10i plus 6j plus 2k. So there are these hats on each of these basis vectors, indicating that they are of unit length. And this velocity vector, well, each of the coordinates is sort of miles per hour. So I have given you sort of the units, the speed of the bird, which is the length of this vector, is in miles per hour. And the question is, how many seconds does it take the bird to climb 0.3 miles? So 3/10 of a mile. How many seconds does it take the bird to climb that distance? And it's very important that you read the question right. So climbing a distance means an increase in the altitude, right? So in the upward sort of the vertical direction, which is usually it's the z component of the position. So I'm imagining my coordinate system to be set up so that the z-axis is pointing upward, and climbing 0.3 miles means that the position of the bird is given by a point initially, and by the end of this climb, the third coordinate will be increased by 0.3 miles. And be careful, because it's this velocity vector is given in miles per hour, and I'm asking about seconds. I'm asking you to give me the result in seconds. So there has to be sort of a conversion at some point. I mean, it's a silly exercise, but hopefully it all makes sense, and it's kind of well, it's more fun than just to say like, here is a vector, do some calculations with that. Okay, lots of answers. So it takes a bit of thinking and a quick calculation. So again, one has to be careful, because having this velocity vector v with coordinates 10, 6, and 2 in miles per hour means that basically by each hour the bird is moving 10 miles along the x-axis, 6 miles along the y-axis, and 2 miles along the z-axis. So that's the point of the whole thing, of this velocity vector. Of course, the speed of the bird, which I'm actually not asking you to calculate, but the speed of the bird would be the length of this velocity vector, right? So what I'm actually asking is to calculate the number of seconds needed for the bird to climb vertically up 0.3 miles. I hope this was a good hint or something that you could use. Okay, I think there are like something like 40 something votes, so feel free to head over to itempool.com/math1055/live and input your answer in that box. Okay, I don't see many new submissions coming in, so let me close this one as well. So let's see. Okay, yes, I think I clicked it. So yes, the correct answer was 540 seconds. And let me quickly explain why that's the case. So here is well, my badly drawn coordinate system. So we are working in three-dimensional space. X, Y, and Z are our coordinate axes, and we have this velocity vector v. Let me just try to zoom in. Velocity vector v expressed using these standard basis vectors. I hat, j hat, and k hat, which are unit vectors pointing along the positive half of these axes. And this velocity vector has three components. Sort of the x component was 10, I think. The y component was 6. And the z component was 2. So this is very much not to scale. But the point is that each second, this vector is added to the position vector of the bird, meaning that each second, this bird, well, not each second, sorry, each hour, this vector is added to the position vector of the bird, and that is the new position of the bird. So each hour, the bird is climbing 2 miles, right? So let me just say that the bird is climbing 2 miles per hour. Okay, and basically the question was how long does it take for the bird to climb this distance vertically? So that's just calculating this difference, and that this gives you basically 3/20 of an hour for the time that we asked. So 1 hour is 60 minutes. So divided by 20, that's 3 minutes. 3 times 3 minutes, that's 9 minutes. And 9 times 60 is just 540. So 540 seconds is the answer in seconds. Okay, so that was the whole idea behind this problem. I hope this was clear. So let's see the next question, perhaps. If you have questions related to either of these, any of these questions, just feel free to ask. So now this is a simple question. Okay, so this is the kind of boring question I could have asked instead of flying birds and chemical equations and stuff like that. So here we have the following problem. What is the value of this scalar, this positive number s, so that s times the vector v is a unit vector if the vector v has coordinates 1, -3, and 5. Okay, so the question is, what number do I have to multiply v by, so it shrinks or stretches to unit length. Because hopefully you recall that multiplying a vector by a positive number can mean that the vector gets sort of stretched if the number is greater than 1, and it gets sort of shrunken. It shrinks if the scalar that we multiply the vector by is between 0 and 1. And here we have to choose the scalar s, so that s times v has length 1. Okay, so this is a simple question, but this is something that we have to do many times, not just in mathematics, but also in physics or in statistics. When you have, for example, in stats, when you have sort of data, a histogram or something, and you want to calculate frequencies or relative or probabilities, you would like to get numbers which are between 0 and 1, but sum to 1. So you would sort of normalize things just like you would normalize a vector to get it to a unit vector. And in physics, it's the same idea. Often you have to normalize your physical quantities because it's only sort of their length is not important, but so you can normalize everything to be of unit length. Okay, I see something like 40 people already have voted. Let me, well, you can probably see the link in the chat, but let me just put it there again. So we still have a few minutes from this lecture. We'll probably have time to go to the last question as well. But this one is important. I mean, this is a very basic question, but it's important that everyone understands how it goes. Yes, I was actually going to say that, but I don't want to. Yeah, I don't want to jinx it. This might be the first time that we actually get to the last question. I tend to overestimate what we can do, but I guess that's still better than underestimating it and then having nothing to do. Okay, I don't see many new submissions. I hope that's because you just think it's too easy to bother. Okay, so James, you asked, is the fact that we miss some questions each week that bad? Are we missing out on anything important? No, definitely not. So the way I sort of construct the list of these questions is that sort of the last one or two questions are always kind of optional and would only add to the experience, but you are not missing anything important. I always post these put these last questions in the Teams chat, but as you can see there, they are sort of optional questions. Let me quickly finish this one, because I hope you have all had enough time solving it. Okay, so this is interesting. Some people have said that it's 1 over the square root of which is true. Okay, so actually I messed this one up. It shouldn't be root 35. It should be 1 over the root of square root of 35. So that's my bad. I was already thinking something else. I don't know. This is my bad. It should be 1 over the square root of 35. Let me just show you why. I mean, this is something that I often do. I sort of messed things up, even though I know how to calculate them. That's well, that's just life, I guess. So the point is that we have this vector with these coordinates 1, -3, and 5, and we want to take a multiple of this vector, so it's turned into a unit vector. So s times v should have length 1. And you might know, I mean, this is just the point of multiplying a vector by a number, that the length of a scalar multiple of a vector is just the length of that vector multiplied by the absolute value of that number. So we can actually find out what s is if we divide both sides by the length of v. So the absolute value of s is 1 over, and this is important, this is something I messed up, the length of v. So that's 1 divided by the square root of the squared sum of the coordinates. So 1 squared plus -3 squared plus 5 squared. And that's just 1 plus 9 plus 25. So that's 35 under the square root. So this is the absolute value of s, but if you look back and remember, I asked for a positive value for s. So s actually could be plus or minus 1 over root 35, but since I asked for a positive value, s should be plus 1 divided by the square root of 35. Okay, so that was the idea here. Yeah, I mistakenly giving you the wrong solution there. But anyways, here it is. Okay, so the last question before we end this lecture is about well, it's a physics question, but it only sounds sort of physicsy. The point is that we have this force acting on an object, moving an object from point A to point B, and we are asked to calculate the work being done by this force. And there is the hint telling you that the work along a line segment is nothing but the scalar product of the force and the displacement vector. So the displacement vector is just a vector connecting point A to point B. And the scalar product is something that, well, we didn't have a video on it, but I can quickly tell you, well, hopefully you all remember it from high school or secondary school, that is just where it can be calculated in multiple ways. If you have two vectors in space or in the plane, let me just quickly switch to the so if you have two vectors, vector A and vector B, with coordinates A1, A2, and A3, and B1, B2, and B3, you could calculate the scalar product in such a way. You just multiply the corresponding coordinates. So coordinate by coordinate, you multiply them and add those up, and those products up. Or geometrically, you just take the length of each vector and the cosine of the angle between these two vectors and multiply these quantities to get the scalar product. These two things are equivalent ways of calculating the scalar product. And in this problem, what I'm asking you to calculate is f times the vector f multiplied by the vector AB using the scalar product. Okay. So it's the first, it's the coordinate calculation that is needed here. Okay, I'll finish the vote in a minute, and then I'll let you go. Let me just wait a few more seconds so people can input their answer if they want. So of course here the work is sort of done along a line segment, so a straight line. If we would have more complicated path, like some sort of curve, then we would have to do an integral. So that is something you would learn in calculus or later on. But work being done along straight lines is kind of easy. Okay, let me just close it and show you quickly the answer. Sorry if you didn't have time to submit your solution. So it was 7 joules, and basic idea is that you have to calculate this scalar product. The vector f was given by these coordinates, and the points were given by these coordinates. So b was 4, 2, and a was 0, 3. So the vector pointing from A to B is 4 minus 1. And so if I calculate the product of the coordinates added up, I get 8 minus 1. So that's just 7. So that was the work. Okay, so it's 7 joules. All right, I hope this was clear. You can of course watch the recording of this video, which I'll upload as soon as I can to the usual places. So this is the end of this live lecture. Thank you all for attending, and take care, stay safe, have a nice weekend, everyone.